Good morning, everyone, and welcome to this S2S4E webinar. Today, we will explore the hydroclimate forecast from May to July. I'm Ilia Pechlivanidis from the Barcelona Supercomputing Center, and our speaker and member of the S2S4E project team is Ilia Pechlivanidis. Ilia is the scientific leader in the forecasting of water variables at the Swedish Meteorological and Hydrological Institute. Is project manager of the European Flood Awareness System Dissemination Center, which is under the umbrella of the Copernicus Emergency Management Service. In addition, Elias is the co-chair of the Hydrological Ensemble Prediction Experiment Scientific Initiative, and is reference group member at the Center of Natural Arts and Disaster Science. His work is focusing on short to medium range and subseasonal-to-seasonal hydrological forecasting with application in Sweden, Europe, and the globe. This webinar will last about 30 minutes. You can post questions at any time using the chat, and we'll try to answer as many as possible in the Q&A session after Elias' presentation. So Elias, the floor is yours.
Thanks, Ilaria, for this nice introduction. Prior to my presentation, I want to wish to all participants to be safe and healthy. So today I will speak about subseasonal and seasonal hydrometeorological forecast over Europe for the coming months. And before actually sharing the predictions, I would like to thank researchers and developers at SMHI and also at BSE, in particular Frederick, Thomas, Luis from SMHI, and Andrea and Francesc from BSE. So in this webinar, I will present the reasons that we focus on the hydropower sector, and also the needs for these managers when it comes to decision making at the long term, and also what we've been doing here in terms of science and development to address those needs as a component of the climate service that we provide. Also, I will present you the status, the past meteorological status from months from January until March, and then I will present the forecast for the coming spring flood season, which for us is the period from May until July, and then we will have questions and answers. So why are we focusing on the hydropower sector? The hydropower is actually the world's largest source of renewable energy, and it accounts for about 16% of the global electricity. And that means that there is a high unused potential to be explored, particularly in times of a changing global energy policy. So it's actually important here to note that only in 2017, about $48 billion have been invested in hydropower projects. And that highlights the fact that there's enormous market potential for cost-saving solutions. In Europe, there's also a high market potential, and this is depicted here in this figure from the IHA, the International Hydropower Association, showing the installed capacity per country. While in this figure here, it shows the high number of hydropower dams that exist in Europe. So that indicates and highlights the high potential and the high interest in this specific sector. There's also an example as a case study, and I will briefly present it here, but please note that this example is better described in the fact sheet that you can find in the handouts and also in the website, and is a case study in northern Sweden. Here I just present you some forecasts, seasonal forecast for precipitation, snow, water equivalent, and inflows. And the reason that we are focusing on these variables is simply because there's interest from the hydropower companies. In this specific event, in spring flood 2015, there was a very high precipitation event. It's about 300 millimeters precipitation. And that is considered even above the extremes that we have observed in the past climatology. And that was an event that was very difficultly predicted. And nevertheless, there's a lot of snow, as you know, in northern Sweden. So it's important to quantify the existing snow and how and when this snow is going to melt, simply because this snow melting and the precipitation is going to result into inflows to the reservoir. So every overestimation or underestimation is going to affect the inflows to the reservoir, and consequently is going to affect the production. Here, there was, in terms of snow, there was an okay, I would say, estimation of the snow water equivalent, not very accurate in terms of the actual value, but at least there was an indication that in terms of snow water equivalent, we were below normal conditions in 2015. But nevertheless, the precipitation event was not able to be predicted. The forecasts were showing, even from 3 months in advance, 2 months in advance, and 1 month in advance, that precipitation is going to be extreme, but not to that level, actually. And consequently, that led to underestimation of the inflows to the reservoir, and also to a release of water that did not result to energy production. And that also means that there could be a case with thousands of euros or even millions of euros being lost if these forecasts are actually not accurate. So if we're making, as climate service, a good estimation, then we could increase the added value for the hydropower companies. And here it's important also to understand the needs before we are setting up these services. So hydropower companies, they have regulation schemes, and nevertheless, the dam regulations that they apply affects the production. And this production is impacted by variability and also extremes in weather, climate, and hydrology. The reservoir operation is done considering multiple uses of water, so not only hydrology, for instance, including environmental uses. And the management needs to handle the peak demands in electricity and also to contribute to the supply-demand balance. What I'm showing here in this figure is a very typical example for Sweden, where the blue line depicts the natural inflows to the reservoir. So you can see here a very nice spring flood season from May until the end of July. And then we have the recession. But this type of signal is not meet perfectly the signal that comes for demand, energy demand, which is much smoother. Consequently, that means that there is a period or a set of months that we have surplus of water, which is actually this period here, and there's a period in autumn and winter where we have deficit of water in order to meet the energy demands. That also indicates the fact that we have to store, if we want to meet the energy demands, that we have to store water that is available in the spring flood in the reservoir in order to release it later in the year and meet the energy demands. So currently the hydropower companies, they are using climatological precipitation and temperature and samples in a hydrological model in order to make long-term forecast, long-term hydrological forecast. But there's been little improvement in forecast over the past 30 years when these methods or decision-making were simply based on past climatology. And this is where we are bringing the added value by introducing in this decision-making process climate and meteorological forecasts coming from prediction models from different data providers. And also, when we are talking with the hydropower companies and people from this specific sector, we are just requested with different type of information. The first thing is they want to know, of course, what are the inflows to the reservoir. And as drivers, as forcing input to that is precipitation and temperature. Precipitation is important because it is the water that will result to the reservoir. Temperature is also important because in a snow-dominated and river basin and environment, temperature is going to affect the snow accumulation and snow melting processes. And it is very important to know this specific water storage in the river basin and when this water will be released, so from snow to become runoff, simply because that is going to define the onset of the spring flood. So it is for us important to know which specific week in the year the hydrograph is going to start increasing and the water will result to the reservoir. And it's not only forecast in a deterministic way or in a probabilistic way, and for us to tell them which week of the year we're going to have the spring flood, but it's important to communicate to the users what is the forecasting skill. The skill is an indicator of how much trust the users can put in this actual forecast. So this is what we have been scientifically calculating and estimating, and then we are communicating to the users. It is important for them to have the initial conditions, such as snow, and also to improve the initial conditions and also to improve the weather forecast. So what is our approach to address these specific needs? Over Europe, SMHI has set up a pan-European continental hydrological model. This model is called eHype. There have been different versions, different improvements of this model. It's a process-based hydrological model, meaning that we can represent processes as snow, groundwater, and also human impacts, like, for instance, the irrigation practices or even the regulation schemes at the dams and the reservoirs. This is the domain that we are covering. The resolution is very fine, especially we have about 35,000 catchments represented over Europe with a median size of 215 square kilometers. And this is a spatial resolution much finer than the meteorological forcing data forecast available from different providers. In order to set up the model, we have been using open data for topography, land use, soil, lakes and reservoirs, water flow, and evapotranspiration. And we have been calculating the parameters of the model. So there's been a very heavy work on improving the model performance. And I think we're at a good stage, actually. More information about the hydrological model can be found at SMHI's website under the hydweb.smhi.se. And from this hydrological model, we are calculating two indicators that we have defined with some users in Sweden. And these indicators is the snow max anomaly and the inflow anomaly. They are calculated at time aggregation windows of weeks, since we are providing some subseasonal forecast of those indicators, and also in windows of months, driven specifically from the seasonal forecast. that we are getting from ECMWF, CIS5. And this is an example of how we're actually calculating these specific indicators. So for snow max anomaly, what we are doing is that we are taking windows of 7 days, and from those we have the long-term mean in order to calculate the anomalies. And since we're interested on snow max anomalies, for every week we are identifying the maximum daily value, and then we are calculating the difference between that value and the long-term mean. Now, when it comes to the seasonal forecasts, which are defined for every month, there we're just taking the maximum daily value that exists within the month of interest. For the inflows anomalies, it's slightly different. For the weekly windows, we are calculating the mean values over these 7 daily time steps, and which is actually these lines here. And from those lines, we're just calculating the anomalies to the long-term mean. And then when we are focusing on the seasonal time scale, then there we're just calculating the mean over the 30-day period. And from that mean, we're just estimating the difference to the long-term mean. So these are the indicators together with meteorological indicators that we are inserting, we are providing to the S2S4E Decision Support Tool every week for the subseasonal forecast and every month for the seasonal forecast. And we are very proud as a consortium to say that these indicators are now available since the past couple of weeks. So if you have registered to the Decision Support Tool and you have access, then now you can find under hydropower, and you can find indicators about inflows anomaly and snow max anomaly. And this is a very sophisticated platform and DST tool, since it is not only providing you with outlooks of different variables, telling you what the future is going to be in terms of normal conditions. So for instance, if we're going to have above normal conditions depicted here with blue, or we're going to have below normal conditions depicted here with orange. But you have as a user, you have the potential to define what is the trust of the forecast that you're gonna put to the tool. So we have been calculating different metrics, forecasting skill metrics, and these are available. And just by changing a cursor, then this outlook is more interactive based on your needs. If I click on one specific point there, then I'm going to have a summary table here telling me information of how much of this probabilistic forecast, so how many ensamples are above normal conditions, how many ensamples lie within the normal conditions, and how many they are below normal conditions. And also how much is the skill being already pre-calculated. So there's a lot of information there. You have the potential to go through and just play. So if I proceed now with the analysis of the past meteorological status, and this is very important because based on that, we can have an understanding of what are the initial conditions that they are driving the hydrological model later. So these are the reanalysis based observations for January and February over Europe. So you can see here that the Northern Europe in generally, we had above climatology conditions. That means that we had more precipitation than usually, while in Central Europe was drier than usually. And then in the east part of Spain, there was also conditions quite wet. Now, when we proceed further to February, then it's a very much well-defined over Europe, where we're having Western and Central Europe and even Northern Europe and Eastern Europe very much wet conditions, while in Southern Europe and the Mediterranean, the conditions were quite dry. And as an example here, I just took 2 cases in Stockholm, in Sweden, in Barcelona, also in Spain, depicting the observations, which are here, the black lines for the month of February. And what is these graphs are actually shown here. The dark blue area is the normal conditions, and then here the lighter blue are actually the extremes. So this is the high extremes, and this area is the low extremes. So you can see here that, as I mentioned earlier, that we have wet conditions, that the total precipitation for these weeks was always above the mean climatology. While in the case of Barcelona, there was always lower than the climatological mean, and even reaching the points of extremes. So that we had extreme dry conditions. For March, the patterns are slightly better. We had dry conditions in Central Europe and in the UK, while in the Mediterranean, parts of the Mediterranean, and also in northern, in the Scandinavian, we had wet conditions. These patterns, together with the temperature cases, are very important, because they will tell us exactly how much of this precipitation is actually stored as snow. And the seasonal forecast already from November and October, they were showing that we're going to have very hot winter in comparison to normal conditions. And this is the case, as you can see here, the whole Europe for January, February, even on the case studies that we have in Stockholm and in Barcelona, the conditions were very hot in comparison to the past climatology. And also that was the same case for March. But although we are referring here to saying that we're going to have the temperatures were higher than normal, this doesn't mean that the temperatures were not less than 0 degrees, meaning that the precipitation was actually stored in the Scandinavia in the form of snow. Hence, we were having quite a lot of snow, which would melt later in the coming months. So now let's see the forecast for the upcoming months from May until July. And these are the subseasonal forecasts. Here is the information that you can also find in the S2S4E DST tool. These are the forecasts, the subseasonal forecast for this week, for the next week, and then the week after. It's for precipitation. Whatever you see here as dot with yellow color, that means that the conditions are going to be below normal. If it is blue, then the conditions are going to be above normal. And if it is gray, that means that we are in normal conditions for these specific weeks. And if you see a triangle, that means that these conditions are reaching the extremes, either the high extremes or the low extremes. So as a conclusion for these specific weeks, we are having high probability of being below normal conditions in the UK and also in the Eastern Europe. While here for the week after, these below normal conditions are observed in Italy. In the Scandinavia, there were some regions that we were having above normal conditions, but these were not very statistically, I would say, significant. Now, when we move into 2 weeks into the future, then we have high probability of being below normal conditions in the Balkan regions and also in the northern areas of Scandinavia. Now, when we proceed to temperature subseasonal forecast, here the colors change. So we have red for above normal conditions and blue for below normal conditions. The same thing applies here with the extreme, the triangles. So what we observe is that we're having high probability of being above normal conditions in the Western Europe, in Denmark, in Norway, and also in Italy. Now for the week ahead, we have high probability of being above normal conditions for east and west Mediterranean. And also we are having below normal conditions in the northern area of Scandinavia. And then when we see 2 weeks ahead, then we have we see high probability of being above normal conditions in the Western Europe, in Scandinavia, and also in some countries like Austria and Slovenia. Now, when we proceed with the seasonal forecast, there we have for May, for precipitation, we have high probability of being above normal conditions for the Scandinavia, like Norway, Sweden, Finland, France, as you can see here, and also the Balkans. There's for June, we have below normal conditions for the Southern Europe. And then for July, we have above normal conditions for Scandinavia and below normal conditions for the Southern Europe. For temperature, we observe that we have high probability for being above normal conditions in the region which is around the Baltic Sea, as you can see here. In June, you see that over Europe, there is nothing like significant. So that means that we have normal conditions, or that our forecasts are not having skill to communicate to the users. While in July, then there is a very high probability of being above normal conditions in Scandinavia and also in Eastern Europe. And this is very important, as I mentioned earlier, since it's going to affect our hydrology. Now, what we see in terms of snow max anomaly forecast is that in most part of the Scandinavia, here we're only depicting regions where snow is actually observed, like Iceland and then the Scandinavia and also the Alps here. We can see that in most part of the Scandinavia, then the conditions for snow max anomaly are above normal. And that was making sense since there was precipitation already present with low temperature degrees. So there's still snow there, but this snow is actually reducing. It's becoming part of the mountainous regions in Sweden and in Norway and also in Finland as we go further to summer, like June and July. And then we have the inflow forecast anomalies. And here the pattern is more or less the same for Scandinavia, where we're having river basins with forecasts being above normal conditions. But also we're having regions, as you can see here in Eastern Europe and in the southern part of the Scandinavia, where the inflows are below normal conditions. Of course, there are other regions over Central Europe and Southern Europe where these patterns are a bit mixed. So it depends on the river conditions, I would say. So these are the forecasts, the meteorological and hydrological forecasts for the next months. And here is where I stop presenting the results. I can just inform all the participants that there is much more information provided in the S2S4E website. So their webinar series that took place in the past available on the website, and this specific webinar is recorded and will be available on the website in the beginning of next week. Their monthly subseasonal and seasonal outlooks available, distributed to our partners every month. There are a number of case studies as fact sheets that we are describing, and these are interesting for the users to have a look of how we have been addressing and improving the forecast for specific case studies defined by the users. And also there are reports demonstrating the science and the value of the DSTE. And since this presentation is also available as a PDF over the handouts here, you can always have these links with you. Here, I would like to thank you all, and I'm now ready to receive questions. Thank you very much.
Thanks to you, Elias. Thank you very much for your presentation. So I think we're receiving many questions. I'll try to pick some, and the rest we will answer at the S2S4E.bsc.es if there are some questions, if you have more questions that we cannot answer now. So the first question, it's from Mubashir Hussain, and is asking, how accurate is your weather forecast? For instance, precipitation or temperature. This is also in line with another questions that ask how much trust would you put on the variables that you're providing in the decision support tool. So
yes. Firstly, I would like to thank them for this question. It is a very valid, actually, question, because everything everything is subject to the forecasting skill. Here, I would like to say that we have two different systems. One system is actually the subseasonal forecast, and we have been calculating the forecasting skill at the weekly time steps for those forecasts. And then there's another system that is on the seasonal time horizon. And for that, we have been calculating the meteorological and hydrological forecasting skill at time steps of months. And everything is actually available over at the DST. I want to say that forecasting skill is actually present over Europe, but the time frame, let's say, or the time horizon that we can put trust in this meteorological forecast depends on the region and depends on the initialization month or initialization week. What we have seen in general is that we can trust the subseasonal forecast up to 2 weeks or 3 weeks into the future, and then we can trust the meteorological seasonal forecast 2 months into the future. And then the skill kind of like drops. But everything, as I mentioned earlier, is subject to the region of interest and also to the month of interest. So there's no clear, let's say, answer to that. Everything is subjective. I would recommend these users to go to the region of interest and even through the DST to go and see what is the forecasting skill for the coming months. Now for hydrology, if I may say something about that, this is a different situation because hydrology is not driven only by the meteorological forecast, but it depends on the initial conditions, and the forecasts are also dependent. The forecasting skill is also dependent on what we call in hydrological terms as river memory, how fast the river is responding to the precipitation signal or how slow it is responding. So since the hydrological processes, they have longer memory than meteorology, then we very usually observe that hydrological variables, they have higher skill than meteorological variables. So we can put more trust on those. Thank you.
Thanks to you, Elias. Another question comes from Laurent Dubout and is asking, on the slide on precipitation analysis, you use JHRA 55. Is there a particular reason for this rather than using ERA 5?
Thank you to Laurent. It is a good question. To be honest, I do not have a clear and immediate answer on that. Different variables in the DST are provided from different partners within the consortium. So I would have expected that there is a specific, let's say, competence from our partners that provided the meteorological forecast with this specific system, and that is the reason behind it. it's important here to know that these forecasts are also bias adjusted prior to being disseminated in the DST, and also the bias adjustment method depends on the I would say in-house competence of the different partners. So it is a very much collective effort and very much joint effort on that. Thank you.
Great, thank you, Elias. There are many people asking about, they noticed that we use CFS version 2 as weekly subseasonal guidance, and they're asking why instead we do not use the ECMWF. As we've been already answering in chat, just for everyone to know, we are switching the subseasonal forecast to the ECMWF extended range forecast system in the next weeks. So,
sorry.
Yeah, if you have something to add, go ahead.
I think the answer again, well, first, thanks for the question. And I think the answer again lies on what I mentioned earlier, which is on the competence and the experience of the partners providing those forecasts. I would say that for the forecast that SMHI has been using to provide the snow max anomalies and the inflows anomalies, so the forcing inputs, the meteorological forcing input to the hydrological model, these forecasts are actually based on ECMWF products, simply because SMHI is an ECMWF partner, has access to the data. So we are using the extended range forecast for the subseasonal time horizon, bias adjust those forecasts, and then we ask input to the hydrological model. And it is the same case for the seasonal time horizon, where we are using ECMWF SIS5 bias adjusted meteorological forecast as input to our hydrological model. So ECMWF data are also used in parts of this modeling chain. Thank you.
Thanks to you, Elias. As we have over 100 participants, we're receiving many questions, but unfortunately we're running out of time, so we take care of answering all your questions during the next days. I want to thank you, Elias, for the presentation, and all the participants for their active participation. Thank you also to Anga Nicodemo from BST that she supported to organize this webinar. I hope you enjoyed it, and please, when you're exiting the webinar, a tab will open with a short survey. Your answer is really important for us, so I encourage you to answer the survey if you can. You can contact us for more questions at S2S4E@bsc.es, and we and Elias will be available to answer, as I said previously. We will also publish the slides and the recording of the webinar on our website. So stay tuned for next webinars, and especially stay safe. Thank you.
Thank you, Laria. Thank you all.